Welcome back to Made Up of Wires. Loud. It's loud. All right. We're decompiling Castlevania Symphony of the Night. If you want to know more about the Castlevania Symphony of the Night decompilation project, go to soten.z.dev where you'll see progress on the various overlays that we've been decompiling. I'm a little early this morning. I know that some of you are dealing with daylight saving time, not me. But I have other things to do, so I have to start a little early today. So apologies to anybody who wanted to join in and can't do it. It's going to be a short one as well. But we will get going. So we've been working on the Faerie familiar. There's only a few functions left. We banged out a bunch of them yesterday, and let's see what else there is to do. I have been working on this one that we started, I believe, last week. There's still more to do here, but really it looks like just register mismatches. So it's pretty close. The PSP version is also really close. Obviously, a lot of immediate values that are different. A few instructions here and there that are different. But that one's pretty close as well. So I'm going to keep working on those offline. I might post these to the Discord as well and see if anybody can figure out what might be going on. It seems like there may be an extra variable that that either is being shared that I don't know about or shouldn't be shared. And there's a few more things that I can try to permute this, but I'm not going to work on that today. We're going to go and look at where that Faerie familiar is in the list, see how far things are along. Faerie familiar is TT002. And it says we only have 18% of the code, but I don't think that's correct. I think that is broken for some reason, and we're going to figure out why in just a second. We're going to go back and I am running the permuter on that other function that we haven't solved yet. I am going to do a clean build. Actually, I think this might be okay. Let's see what's left in Faerie familiar. One left, just one. All right, so let's see if anybody started working on this, and if nobody has, we'll work on that. Otherwise, we'll find something else to do. I'm going to keep these open. Nobody's started it, so it's ours for the taking. If you're just joining, we're decompiling Castlevania Symphony of the Night. I'm usually scheduled about an hour later than this, but I have some conflicts today. Early school release means I have to make sure that kids are picked up and at their activities. So I'm going to find this function. And get that assembly. And I don't know if we looked at this one at all yesterday. I don't recall specifically. I don't remember what this one looked like. Okay, so it's a drawing function. We have a lot of function signatures that we need to supply, and just a few globals that we need to figure out what their types are. So let's start doing that. I'm going to flip over here and do this mostly in the terminal. I just want to make sure that I get the right signatures for these, because that will make life easier later on. The watch keeps beeping. Oh, I need to charge it. What a world we live in where our watches need charging. I think that must be what happens when you get old. You start questioning all the things. And this one has a larger signature. I might look at this in dupes as well and just make sure that this function hasn't been identified as a dupe. Let's do that before I get too far into this. Oh, bummer. There we go. It doesn't appear to be a dupe. So we can continue on. It turned out that one of the functions that I looked at towards the end of the stream yesterday was a duplicate. So it's always good to check. But it was a shared, already pulled out as a shared function. It did look like somebody else had tried to decompile it, I think just by importing the shared implementation. But it had some trouble, and there's a comment in there about how something like the jump table wasn't aligning, but I didn't see that problem at all. So I'm not sure what the issue was there. It would be nice, I always say this, but then don't have the time or don't take the time to set up an emulator, but it would be nice to see what where these functions are called and what is going on specifically. Like I've said before, I've not spent a lot of time in the familiar code, so I'm not. It's not like weapons where there was a lot more. What's going on? So my context is broken somewhere. There we go. So this was able to determine one more type here, which is helpful. It also is giving us a hint that we're going to have a new entity extension that we're going to need to figure out the type of. So there's a few of these here that we probably need to go through and figure out as well. So let's look at those in the code, and then we'll go through and look at them in oh, sorry, wrong. So all the signatures are worked out. I decompiled once again using M2C. And so then what's left is these three that don't have types. And it looks like there is at least one additional type that now M2C is not sure of. Yes, good question, Chronic. There is, and occasionally I'll do that instead of going through and just decompiling, I will go through and try to determine meaning for some of the functions and some of the variables, especially global variables. And that probably leads to as much understanding of the code and how the game is made as doing the decompile itself. And obviously, people have done a lot of work to give nice symbol names to a lot of these addresses that we don't know yet. There certainly is a trade-off in what you do. So, okay, kind of getting back to where I was looking at these types. So this is a some structure of size 12. So we can look at what our size 12 structures are. I'm going to go look at the data first and then do a search for structs of that size. Yeah, naming is super important. What do they say about computer science? Cache cohesion and naming things are the two hardest problems. We're the only function that uses this data. And so starting out, it actually doesn't look like a struct like we normally would see, but it does have a pattern, and I think the pattern is we're going to have two 32-bit values. It's possible that these are something other than 32-bit values and a pointer. Let's do a quick search for things of size C. We have a few of them. So all of these so far are unlikely. Yeah, so I think we have a new type here that we need to define. And I'm going to assume that it's two 32-bit values followed by a pointer. And our pointer, we can see if we know what that is yet. We don't. The pointer looks like it may be one of those other graphic structures. So those look like 32-bit values as well. Oops. So this is our CPO, 2 CBO. Yeah, it's kind of a bummer giving these names like this, but that is what we have at the moment. So this is going to be an array of these, and we can throw that into the context and maybe get something slightly nicer from M2C. Maybe. I will do this too. I'll take. Yeah, there's a few of those mnemonics, yeah, that I can never get past as well. Like SLTI, sign less than immediate. I want to usually say shift less. So these kind of look like the same thing. This one So this is referenced, and it's one word or 4 bytes away from this other variable that we know. And this is going to be a little bit tricky, but not terribly tricky. This is, it is a reference to this same array. It's just accessing the second field. And so the compiler has pre-computed the address. So we can give it the same type. I'll give it the same type for now, but we need to remember that we're accessing the second field there, as opposed to it being its own thing. That will give us a slightly nicer decomp, I'm hoping. Yeah, there we go. And then we have this last one. And that's the same thing. This is just the third field, so this is the pointer value here. So it looked like 3 things to solve, but it turned out to be just 1, which is nice. And then I'm going to take this decomp and use the latest one that was produced. There is this, still have to deal with this struct, and we can see where that is. Nothing is referencing it that I see. So I'm gonna get rid of it, and we can deal with that one in a different way. I turn off built-ins to get rid of those warnings. I mentioned before that can cause some issues in some places, but that's usually how I deal with it. There's one more here that I missed, which is a void pointer. We will have to resolve this type. For now, I'm going to say that it's a 32-bit pointer. Actually, let's look and see if we can find that data. Yeah, that says, I mean, it doesn't look like a 32-bit pointer. It looks like just a 32-bit value. It could be a pointer though, because the pointer would be 32 bits. So what it's pointing to, we don't know yet. It may not be a pointer at all though, because the only way we're using it is to do some subtraction. We're not assigning any references or dereferencing it, so I'm going to say that that is just a assign 32. And get a decomp one more time. If we can have the machine do as much work for us as possible, that's optimal. So I always get rid of these. So player underscore we can replace with player dot. Player is a macro used to reference the first entity. That will break a few things because there are nested structs that we need to resolve properly. Okay. These should be in the context already. I don't know why they've... No, they're not in the context. That is odd that they're not there. Tile map. Yeah, so it looks like these are struct access as well. So I'll do the same thing with tile map. All right, which other ones do we have here? Let me look at target location. I don't know that I have this in the context either. I don't. This may be a struct as well. It's not one that I'm familiar with. Let's look at these other errors. Line 29, there is a... so it's pulling in the generic entity, and so we're not going to be able to use that. I'm going to assume that this is the Faerie familiar, and we'll have to pull up the struct for that to see what these offsets are. 43 is the next error. Same thing here, we're just accessing the wrong... we're going to have to replace all these extension fields. 107. Seems similar here as well. All right, so let's start doing that. Any of these self EXTs are going to need to be fixed off screen. I'm going to be looking at the Faerie familiar structure. I'll flash that up for a second. Assuming that this is the Faerie familiar. Some of these fields may not, I think these are ones that I just recently, actually there's some that haven't been split as well. So I had split these were originally padding and renamed timer. So there's a name that didn't exist before. And so now it looks like we're gonna have to dig into these at offset 98. And we won't know what those are quite yet, unless we can tell from context. It does look like assuming var 0 and var v1 are being used for the same thing, it looks like these are a position xy, possibly of the target, and that's confirmed down here as well. So I think we can get away with calling 98 and 9C target X and target Y, and that'll be a nice nice way to reference those. So let's find the familiar. I could give it more screen space. No particular reason. This was a layout that I chose, and it certainly can improve. Oh, it looks like I don't even have the Faerie Familiar. I want to keep, as much as possible, I want to keep the text readable, which is already hard, not knowing how people are watching. And occasionally I have put things up in the upper right-hand corner, graphs and things like that. But there's nothing there now. No reason not to make this a little wider. Okay, so I don't have the Faerie Familiar. I'm just going to steal the context, I think, from here. And it should be safe to grab everything above. That was just another scratch that I had open. So then we're going to be breaking apart this this padding here, and so it's looking like it's going to be 4 16-bit values. Let's confirm that by looking here on towards the beginning. What we want to see is whether we're at offset 98. What are we storing? And actually, we're storing a word. So it is a 32-bit value. So that was good. Good thing that I looked. The other thing that this may be, we're dealing with these integers that are often split between high and low and then accessed either as 32 or 16-bit. It may be a case like that as well, and so there may be something to look at there. Actually, no, this is, I think this is 2 16-bit values, and the compiler has just combined this into a single assignment, and I'll show how that works in a second. That's kind of clever. Sorry, flipping back and forth. So what I want is the left is going to be at 9.8. The x coordinate is going to be at 9a, top at 9c, and then y at 9e. All right, so we could try to get another decompile again and see if it chooses the Faerie Familiar now. We can't really force it to, and it doesn't look like it has picked that up. When I suppose we could force it, and let's try to do that. Let's find the extension union. And just get rid of everything but the Faerie. I suppose I can't do this now because I've already replaced several of these other things. It'd be a little more work to go through and fix these structs up again. So I did want to see if it picked that extension up, and it didn't. Oh, and that's because they're 16-bit values, and this is doing this 32-bit trick. So we'll just have to go through and do these manually, and I'll show what this looks like if I can get there. So this was left, top, and I'll just do a global search and replace for those. I may have these backwards, we'll see. This may be X and Y and not left and top. Oh, and now we have a nice list of other issues to solve here. So it chose the Medusa extension, and so we have to map this. Unfortunately, this offsets array does make that a little more difficult. Oh, and this looks to be renamed. So that starts at 8.4. So this would be Faerie unknown 8.4. And this is kind of an unfun task of fixing all these up. So M2C often doesn't know about sizes, so I'm going to assume that that's 6. It may be 8. We'll see there. Oh, we don't have an 8.4 and 8.6. What do we have? All right, so we have random movement angle. That's nice. All right. No, it looks like it did. So I screwed up that offset then. So it's going to be, it looks like unknown 88 for target angle. That gives us a hint, though, as to what that might be. I do want to see if there's any more of those. There aren't. Some of these I may be getting wrong, but we can check that along the way once we start compiling. I'd rather have something compiling than try to get it right the first time. So here, offset 9. So again, we're at 8.4. Plus 9 will be 9 shorts. So that would be what? 8. Oh, it's 18. 9. 98 maybe? Again, I'm not quite sure here. So this one's going to be 14 off. Possibly this counter. Let's see what it's being used for, if we can tell from that. That was 93. Oh no, this it's no longer. Oh, sorry, I'm all over the place. We'll try going with that counter, and again, if it ends up being something else, that's fine. Just finishing off the Medusas. This is the same, so we can at least be consistent. All right, so now it looks like heart drops. Take a look at the time. 107 is. So these are just pure offsets from the beginning. Unknown. This unknown array starts right at the beginning. These are. They do need to be multiplied by 4. So this will be 40 bytes away, and 40 bytes is going to be, 40 hex. No, 40 bytes. 40 bytes. I was right the first time. In hex, that's going to be 28. So 7c plus 28 is A4. A4 is not part of this struct. It's actually it's in the middle of a this is tricky. So there are certain entities which use these last few bytes. Most of them treat this as an entity, but in this case, oh, this is saying that it's B8. Oh, never mind then. Never mind. I'm wrong. It looks like we have more space in Faerie that we can use. But we don't know what it is yet. So we'll probably have another 16-bit value at A2. And let's see what this is going to be. So this appears to be an array of 32-bit values. So at least 3 of them. possibly a struct. Actually, these, I might be wrong about that. They might be 16-bit values as well. All right. I'm going to assume that this is going to be used for all of these heart drops. So let's... So for the ones that are accessing unknown 2, we'll give them an index of 1. And then for the others, which looks like everything else, we'll give that an index of 0. And screwed up my copy pasta. Okay, a few more, and then we should be compiling, and then we can move on. So we have another index here that was missed from that replacement. I'm hoping that that's what the rest of these are, and it looks like they might be. It's possible that those are structs. It's not obvious at the moment, though. 96. So here we're treating temp v1 as a pointer. And this, okay, so it is a pointer, and it looks like, as far as we can tell, a pointer to a 16-bit value. So that gives us a hint that this is not just a void star, but a 16-bit value pointer. And then that means temp1 is also a pointer to 16-bit values. And here we're actually accessing unknown 8. And that's going to be of this earlier one. And we're going to get some broken symbols because of that, but it's more correct. So here we also have a this appears like we're taking a reference here as opposed to taking the value. That's how I'm reading it. Morning, Orcam. Sorry, I have a scheduling issue, so I'm early today, and I'm gonna end in about 20 minutes or so. Good to have you back, though. Always a pleasure. So let's see what we're gonna do here. I'll leave this T4 here. I think that this is going to end up being the third index. We're compiling, so that's better than... No, just today. The local schools, they get out early, like every other Wednesday, and so you have to go get the kids, take them to activities, all kinds of things. kind of screwy. All right, so we're compiling. I think we can get rid of most of this. By get rid of most of that, I mean keep it right where it is. Okay, so let's go up here. So this is, I mentioned this at the beginning. This is kind of a clever hack that's being done. Let's see if I can replicate it. The shift by 8 is curious, but I think that this is just two different assignments. It's possible that there is some 8-bit values here, but we'll see how this looks, and then if that seems more correct. And it doesn't. I actually expected that to just compile to the right thing the first time. So let's see what might be going on. Our shift lefts are definitely there. It is possible that this is that these both would be bytes. But the word storage, excuse me, indicates that they're not. So maybe I was wrong. So it's possible that this is a struct. What's odd is shifting left, so the left position by 8. That may have something to do with the dimensions of the tile map that I'm not familiar with offhand. So I'm going to, we'll cast this for now as a 32-bit and assign it that way. And that should work, but we'll have to fix it before we're done. And I'm going to do the same to the next one. So we get some slightly different instructions. Some of this, however, is coming from later on. This appears to just be a ordering issue here. I'm going to skip that for now. This looks like it's probably just a pass-through assignment. There is a mask happening in ours, so it's possible that we have the wrong size there. Let me look up that Z priority size. It is a 32. So the compiler was right about that one. I'm not sure where the mask is coming from at the moment. It's possible that the entity's Z priority is a 16-bit value, or player Z priority is a 16-bit value. It is, so it's loading a half, so 16 bits from entity. And yeah, I'm not sure where the why the original doesn't have a mask isn't clear to me. Oh, so we are, it was a 2-step, it looks like. So let's go back here. So I was wrong about how that was being loaded. So now we can start seeing some of these, excuse me, some of these offsets and making sure that they're correct. We have a branch that's going to the wrong place. Not a concern at the moment. All of the rest of that seems fine. Facing left, we always treat that as a Boolean. There is a no-op down here that is getting introduced, and so we need to figure out why. It looks like we may be able to invert this. And these could be backwards, excuse me, or we could be negating the value. So it does look like this is how it was written, but then we're either doing a multiply by -1 or just taking the negative value. Do this one additional way and see. Oh, not times. I'm just trying to see if we can get rid of that no-op in this statement. And it's possible that that no-op is coming from somewhere else. And this may be why. Oh, I've mentioned I'm in a civilized part of the world before, where clocks don't magically change based on the whims of politicians. All right, so this is going to be early. I have to leave in about 15 minutes, which is more of a self-docs than anything. So there's a few things going on here that may or may not be related. It's certainly possible that these are just being set in line, so we can try that. And that, yeah, that looks better. So those var v0 and v1 were unnecessary. Bismurphy, I think I might post one of the other Faerie functions in Discord later. I'm running into some register issues that other eyes might be able to see before myself. So the decompiler has really given us a jungle of statements here. I'm trying to see where. So kind of coming back to what assumptions that I had made before about this structure being a half rather than a word size look to be proving very false. So I'm going to resize those fields. And I'll keep the names, but yeah, I really anticipated that those were going to turn into pairs of 16-bit values and just be optimized away. So this we should just be able to assign directly. Our next issue is here. There's likely other stuff that could be cleaned up here. Maybe not. That actually looks, except for the names being extra long, that looks like it's probably fine. So we have some out of order loads here. Let's get down to where these offset 84s are being loaded. Oh, when I got rid of temp A0, I screwed up this, so I should be better about making sure that I'm pulling the right thing. So it looks like angle to target is probably safe to use in place of temp A0, but let's just check that out to be absolutely certain. Right. That is a different variable, so I think that is safe. We have a bunch of casts that we're going to need to deal with. Oh, and it looks like this was wrong. I grabbed that this is going to be target angle. Oh, maybe not. That is the right offset. Oh, it's just ordering issue. I see. Okay, so there's more ordering issues here. It's probably worth looking at that. I'm going to look at that later. Our cosine function has a lot of casts. Let's see if we can break that up into more manageable statements. So A0 is being loaded up above. So it looks like A0 is actually coming from random movement angle as opposed to but this loaded version of it. So it may need a separate variable actually. So we'll reintroduce temp A0. Yeah, okay. Let me back out what I had then. And we'll just call that movement angle. And that actually looks quite a bit better already. So we have one issue here where on line 48, we're loading this as a signed value. But it should be unsigned. We can look at the other uses of it to see, or we may have to cast. It is possible that this won't have any effect. I do have other changes right now. I should be able to get rid of those though. While that's going, we can keep working over here. So my theory is that this is actually an unsigned, or no, that doesn't work out as well, or possibly that angle to target is unsigned. And we'd have to look at that to see. That doesn't change it either. Angle to target could be an unsigned 16 though. That changes enough that that's not convincing. So there's something else going on there with signs that I'll have to come back and figure out. All right. Get rid of some casts. Most of this is correct, so it does require cleanup, but I'm not terribly concerned with what's there. Here on line 56, I was going through these quickly, and it looks like I grabbed the wrong field. So let's grab the right field. And it looks like, again, down on 58. There probably are several of those that, oh, maybe that was the last one. All right, so our next issue is down here on line 64. This is similar to what was happening up here. The compiler decides to use a register and then do the assignment once when it writes back to memory. But it seems like what happened more likely was that these were direct assignments to that struct and not to a separate variable. This is similar. This is an out of order load to an unnecessary variable. All right. This looks like maybe a mistake when I was fixing up fields. don't see anything related to offset 98 here. I see, there was a load from offset 9C. No, those look like unnecessary loads from 9C. So what? It looks like it was loading from offset 30. So that's params. Yeah, I'm not sure where those came from. What did I do? Okay, so there is some additional work down here that I missed that does need to be done. So let's bring this back. So this looks like it was out of order, which gives us part of what we needed. And there is a store to 9.6. 9.6 is timer. That's actually more likely that, no, sorry. Yeah, so that's my timer. That's my cue to go. I think I am going to leave that here today. We're at 92%. Mostly it's bookkeeping work. This one doesn't look too terribly difficult. Just going through it, we'll see if all the registers end up working out. So far, they have a little bit of mess up here at line 51, but that may work out. If you are new to what we're doing here on Made Up of Wires, we've been decompiling Castlevania Symphony of the Night. And you can learn more about that at soten.z.dev. I'm usually here for about an hour and a half or so. Today is a little short, but I'll be back at the same bat time, same bat channel tomorrow, compensating for all you daylight saving people. I really appreciate everybody who shows up at chat every day. It's a lot of fun, and I enjoy our interaction every day together. But that's it. That's all I have for you. Go to soten.z.dev. Join us in Discord. That's right. Adios. Sorry, Orcam, your message was held for bullying. Don't do it again. No, you're fine. Thanks, everybody. I appreciate it.